Okay, let's continue on hypothesis testing, part 2. I'm going to go over the detailed procedure, complete procedure on testing for the population proportion P. Okay, so we're going to go over the complete procedure testing hypothesis made about the population proportion P. Okay. We use component introduced in the previous section for the p-value method and also the critical value method. Traditional method is critical value method. Methods for testing a claim about population proportions to use the normal distribution as approximation to binomial distribution, using normal to approximate binomial. First of all, let's take the basic method of testing claims about population proportion P. So look at the notation. N represents sample size, the number of phase trials. P hat is probability of success. X represents number of successes. N sample size, P hat is population probability of success. Capital letter P, that's population proportion. Q, this complement of population proportion, which is 1 minus P. So requirements, let's talk about requirements for testing the claim about the population proportion P. The sample must be a simple random sample. Conditions for binomial probability distributions are satisfied. 4 conditions satisfied. Fixed number trials. Trials are independent. Outcomes in 2 categories. And also probability of success and failure remain constant. NP greater than 5, NQ greater than 5. NP is the number of successes. NQ is the number of failures. Are both satisfied, so the binomial distribution and sample proportion could be approximated by a normal distribution, mu equal to NP and then sigma equal to radical of NPQ. This is assumed proportion, not a sample proportion. Test statistics for testing a claim about a proportion. So test statistics z-score. Test statistics equal to p hat sample proportion minus population proportion divided by radical pq over n. P-value, we will find p-value from table A2. Critical value, we can also find it from the table A2. So p-value is different from the population proportion P. P-value is probability of getting an unlikely event, or extreme event. Getting a test that is at least as extreme as the one presenting sample data. P is the population proportion, so they mean different things. You can also use Excel computer programs like Excel, SPSS, and calculator, select TID 384 89.92. Okay. Provide a p-value. So then the p-value method is more convenient. If the technology is not available, then use the table A2. Critical value method. So basically we find out critical, if it's two-tailed test, so find the critical z-score here based on different confidence interval, confidence level. Find negative critical z-score, positive critical z-score, and come up with the rejection region, critical region. Compare the test statistic to the critical z-score and locate the test statistics on the bell curve. This is the critical value method. Okay. When testing claim about the population proportion, traditional method, meaning critical value method and the p-value method are equivalent, and we yield the same results since they use the same standard deviation based on the claim proportion p. Now let's take a look at an example based on information from National Cybersecurity Alliance. 93% of computer owners believe they have an antivirus program installed on their computer. Here this population proportion p, 93%, which is 0.93. From there we know q must be 1 minus p, 1 minus 0.93 is 0.07. In the random sample, 400 scanned computers. So this is a random sample, simple random sample satisfied. Found that 380 of them actually have antivirus software. That means p hat is 380 minus 400, turn out to be 0.95. Then the q hat must be 1 minus p hat, 1 minus 0.95, 0.05. User sample data from the scan computer test claim that 93% of computers have antivirus software. Right here, that's an equal sign here. So the claims HO must be P equal to 0.93, and H1 could be the opposite. So P population proportion not equal to 0.93. So from the alternate hypothesis, we know this two-tailed test. Now, first of all, in order to proceed, when I check the requirement, we have 400 computers random selected, a simple random sample satisfied. And that's fixed number of trials with two categories. So satisfied binomial probability distribution. Requirement for NP greater or equal to 5. Number of successes should be NP, and so NP 400 times 0.93, that turned out to be 372. Okay, and the NQ, number of failures, is 400 times 0.07, which is 28. So they both greater or equal to 5. Then we satisfy the third condition, third requirement. Now using the p-value method, according to the last statement, we know that's a null hypothesis. So the alternate hypothesis would be the opposite. So that's how we set up the null and alternate hypothesis. Then p-value method for significance level, we select alpha equal 0.05 because we are testing a claim about population proportion. The sample statistics relevant to this test is p hat approximated by normal distribution. Now, under the p-value method, p is 0.93, q is 0.07, p p hat is 0.95. Okay, and we know sample size is 400. Based on this, we can find a critical z-score. P hat minus p. This is test statistics z-score. Test statistics. Okay, over square root of pq. And so again, we're piling on the numbers. 0.95 minus 0.93 divided by radical 0.95. 0.93 times 0.07. Dividing by 400, and let's approximate it and run through calculation in the calculator. This turned out to be approximately 1.57. And for the z-score, we run to 2 decimal places. Now, using the p-value method, we know the test statistic is 1.57. So now we'll put z-score here. So area to the left-hand side from the table A2 is going to be 0.9418. Okay, now we use that to find the area to the right, which is the area on the right tail. So it's going to be 0.0582, which is 1 minus 0.9418. So we get the area and then double the area because we have 2 tails, so double the area. Multiply this by 2, you get a 0.1164. And definitely this area is bigger than alpha, 0.1164, greater than alpha. Alpha is 0.05. That means we fail to reject HO. Because p-value 0.1164 is greater than the significant alpha. Fail to reject the null hypothesis. So fail to reject the claim that 93% of computers are antivirus software. So we conclude there's no sufficient sample evidence to warrant rejection of the claim that 93% of computers have antiviruses programs. This is the p-value method. Using critical value method, now the critical z-score, z alpha over 2, it's 1.96 plus minus 1.96, since alpha is 0.05. So area on each tail is 0.05 by 2. Which is 0.025. If you go into the table, look for the corresponding z-score, you find the critical z-value to be negative 1.96 on both sides. And again, this z-score, the test statistics fall outside the rejection region. So this is non-rejection region. And that's why we fail to reject HO. Which also, same thing is, we fail to reject the claim that 93% of the computers have the antivirus software installed. So test does not fall in the critical region or rejection region. Same thing. Critical region is rejection region. So we fail to reject the null hypothesis. So we fail to reject the claim 93% of computers have antivirus software. We're using the confidence interval method. Let me show you how to get this confidence. Again, you get to find out the margin error first using the formula radical p hat times q hat. We know all those. And then construct a confidence interval p hat minus margin. Get a lower limit. And also get an upper limit. And you come up with a confidence interval. all this information are given, so you just have to find out the margin error first. Margin error equal to 1.96 times radical p hat, that's 0.95 times 0.05, q hat is 0.05 by 400. Running 3 significant digits. This turned out to be running through 3 significant digit 0.021. And p hat, we know that, so 0.95 p hat, that's 0.95 minus 0.021, that's how you get 0.929. If you add in 0.95 by 0.021, you get a 0.971. And this is the confidence interval. In this kind of confidence interval, it does contain a population proportion p, which is equal to 0.93. So we do not have sufficient evidence to warrant a rejection of the claim that 93% of the computers have antivirus software. So basically, you have 3 methods to make a last method gives us informal conclusion about the claim.